Hello everyone, hope you're doing well. Welcome back to my channel. Today we're at day 21 of the November Leetcode challenge and we again have a medium question in front of us. It's the first time in this whole week that we're having a question on the 2D array topic, okay? Previously we're having questions on the list, okay, that is a single one-dimensional array on which we were trying multiple approaches, mostly the sliding window approach. But today we are first time in the November Leetcode challenge, we're having a question on a 2D matrix, okay? We'll see this algorithm. But before that, we are only, we are just 9 days remaining in for this particular month to end the daily code challenge for November month. So if you have been doing this till now, congratulations to all of you. Keep maintaining the same pace. You have just 9 days to go, and then it will be always achievement for you. Okay. So let us see what this question is. It's a very simple question. It's a simulation question. Okay. You just have to understand how the simulation works, and if you are able to do that, you can solve this question. As simple as that. This was slightly on the easier side. I will say if you are very good in if you understand how simulation works and if you have good experience in working making solutions for 2D matrix. Okay, let's see the question now. So as you can see, like let me not go through the what they have described. Okay, let me just tell you this in my way. If you see, we are given a grid like this, okay, and you are given the position of guards and walls. Okay, so these are the positions, okay, of guards, and these are the position of walls. Okay, as you can see here, the guards are mentioned by G in this diagram and the walls are mentioned by W in this diagram. So what happens is the guards can see in all the four directions, okay, but their sight will not be beyond if a wall is present. Okay, that is, as in this case we see this particular G, okay, which is there in position 1 comma 1. Okay, it cannot see past this wall. Okay, and the same thing, if a guard comes in between another guard, then also they cannot see for that. Okay, so that is the basic idea. So the idea is very simple. See, if nothing obstructs their vision, they can see in all the four directions. But if something obstructs their vision, what is that? Only two things can obstruct their vision. One is the wall itself and one is the other guard. Okay, as simple as that. So these are something that we'll have to take care while deciding our answer. And remember one thing, while writing the answer, you should not count the position of the wall and the guard. Okay. So what the question here is, we'll have to tell us what are the positions which are not guarded. So in this diagram, if you can see the ones, okay, the one with the green color are the ones which are not guarded, because see, the arrows will show the the direction in which the guard can see that. Okay. So all these red cells are guarded basically. Okay. The white cells are the one which are either walls or the guards. So the green are the ones which are not guarded. Okay, so we have to find the number of these green cells. Okay, so let's see the question quickly. Yeah, a guardsman can see every cell in the four cardinal directions. Okay, north, east, west, south, starting from their positions, unless obstructed by a wall or another guard. Okay, the same thing I told you. Okay, so a cell is guarded if there is at least one guard that can see it. Okay, return the number of unoccupied cells that are not guarded. Remember, we are talking about unoccupied cells that are not guarded. So you should not return the cells which are occupied by a guard or a wall. Okay, you'll have to return the cells which are empty and which are not guarded. So the ones which are highlighted in green this color. Okay, so this is what the simulation we have to do. We'll have to simulate all the four directions for all the guards present. Okay, and we'll have to stop the simulation whenever a wall or another guard comes in the path. As simple as that. Okay, this question is very simple. You see the second example, this is the same thing that we're doing. Okay, so let us see the solution for this. And yeah, so I am starting with the second example. So see, it's just a simulation. I told you in the starting itself, it's all about simulation and how you understand the simulation. Okay, so let me zoom in, let us begin. So if you see, like, the guard in the example 2 I'm talking about is present in 1 comma 1. Okay, so if you see, like, what I'm doing, I am going to simulate all the ways. Okay, till I see, till the path is obstructed by either a wall or a guard. Okay, so I'm at 1 comma 1. Okay, the guard is at 1 comma. That is, the idea here is I will go to all the position which the guards are present. Okay, first of all I will have to create a 2D matrix. Okay, remember, the 2D matrix is not given to us. Okay, we're just given M and M. First, create a 2D matrix and mark the cells in which the guards and the walls are present. Okay, mark them, and then for each guard, basically, you have to start the simulation. Okay, so what you have to do, see, first you'll have to go to all the four directions of the cell till you are obstructed by something. Okay, for example, in this case, I'm starting at 1 comma 1 and I'm going to the right. Okay, what is the right? 1 comma 2. Okay, this is the last cell in the right, and I cannot go beyond that. Okay, so I am stopping here. Similarly, towards the left, I'm at 1 comma 1. I'm going to the left, which is 1 comma 0. And again, I'm obstructed by wall, so I'm stopping there. Same is the up and down. Okay, I'm going to 0 comma 1 and I'm going to 2 comma 1 and I'm stopping there. Okay, see, whenever I'm visiting a new cell once and which is guarded, that is, idea here is whenever I'm visiting a cell which was not guarded previously but now it's being guarded, so you have to just mark as one. Okay, so idea here is you have to, like, use different values to indicate that your cell is guarded or not. Okay, so in my case, if you see, okay, let me run this again to show that. Yeah, so in my case, if you see, what I'm doing is, yeah, in this case, if you see, okay, yeah, these are the ones. So yeah, if it is guard, like ideally if it is occupied, that is either by a wall or a guard, I'm using the -1 to signify that. Okay, in the example that I'm talking about, yeah. And same thing, if it is not guarded, then I'm using 0. So both, if the guard is present in a cell and if the wall is present in a cell, I'm using -1. If it is not guarded, okay, then it is shown as a 0, and if it is guarded, it's shown as a 1. Okay, in this case nothing is guarded, so all the unoccupied cells are unguarded. So the answer in this case is 4. Let us see the example one also. So in this, if you see, basically what is happening is, so I've done the tracing, but yeah, it is too much, I guess. Yeah. So let us come to example one first. So in this, if you see, the ones which are occupied are represented as -1, and the ones which are unguarded represent 1, that is 0, and the ones which are guarded are represented as 1. So I'm using three symbols. So both G and W in this diagram will be shown as -1. The green part will be shown as 0, and the red part will be shown as 1. Okay, as simple as that. So you just have to do the simulation. Let's see the code now, how it works. Yeah, so what I'm doing first I'm creating a grid for the dimension which they have given. Remember, both, it's not a square matrix, so both M and N are different. Okay, so you have to create that first. Next, wherever the walls are present, just go and indicate the same in my in the grid, and same is for the guards. Okay, just go and indicate the same in the guards. I'm using -1 for both of them. If you see here, okay, I'm using -1 for both of them. Next, what I do? See, I'm going to define a function now. Okay, what this function is going to do? So I am going to pass the locations of the guard here. Okay, and one more thing, just remember, by default all the values are coming as 0. Okay, or initializing with 0. So whenever there is a grid, the idea here is whenever there is a guard or a wall present, I'm marking them as -1. Next, I am defining a function. This function, what it will do is, it will take the input as the location of the guard, and then it will go to all the four directions from their location and try to mark if any cell is available. It will mark this as, as you can see, is 1. Okay, it will mark them as 1. So what are the conditions here? See, first of all, it will check whether the cell is the cell that they're trying to visit is whether -1 or not. Okay, if you see here, first I'm going the right. Okay, so I'm going towards the right. Okay, that's how I'm going towards the right. And if I visit a blocker, that is either a guard or a wall, I will break there itself, so I will not continue further. Same thing, if I can visit a cell which is already guarded, I will not do anything and I will proceed. Okay, this connection I'm just showing it for you to understand. Okay, the idea is, see, I'm not writing this again in this case. Okay, if it is 1, I'm not going to write it again, because writing also takes some time, right? I'm not going to do that again. Okay, so this is the way. And other than that, if it is either not occupied, at the same time it is not already guarded, I will add it as something that is guarded. Okay, similarly, I will go for the left. See, the directions here change. Okay, here it is j plus 1 to n, here it is j minus 1 till 0. Okay, it is j minus 1 till 0. In Python, this is how we write that. Okay, again, like we are going up, so let us see that one first. I plus 1 to m, and up will be I minus 1 till 0. Okay, this is how it will be. And then what I'm going to do, I'm going through all the guards again. See, remember, this is the function defined. I've not called this function till now. Okay, this is just the function defined. I'm not called this function till now. Okay, this is where the function ends. Next, I'm going to call this function. Okay, I'm going through all the indexes of the guard. I'm going to call this function now. Okay, then I'm printing this for you to see, and then I'm going to calculate the answer. Okay, I'm going through the whole grid again, and then whichever cells are 0 currently, that will be my unguarded cells, and that I'm going to count and record. Okay, so this is how the code works. This was, but see, if you talk about the time complexity, see, space complexity will obviously O of m into n, because we are creating a grid. If you see that it is clearing all the test cases, I've already submitted this. And second thing is, if you talk about the time complexity, see, what is happening here is, you are missing the grid and marking, that is fine. But remember one thing, one more thing is, since this function is called for every guard, so what will happen is, let us say there are g guards. So at so for each guard, what you are basically doing, you are traversing m, that is, see, the height is whole row, that is what is the length of the row and what is the length of the column. Okay, all the things will you traverse for each guard. So if you talk about the time complexity, it will be, let me write it here for you to understand it clearly. So the time complexity will be, see, of m into n, you understand this, right? M into n will be, because you're using, you know we are going through each of the loops, and for example, this part, if you see, we're using f of n into n complexity. Okay, this one thing, that is first. The other thing is, if you talk about the time consumption of this, see, at max, see, there are m into n elements in the grid. Do you agree with me? Yeah, all of them can be, guards, and all of them can be, one among the guards or the walls. Okay, so in the worst case, this particular code will also take over maintain. Okay, so I've already written that, so I'm not writing that again. Other than that, if you see this particular function, what it does, it will go through each of the guard, and in the worst case, it will be, marking all the whole row. Okay, as let us say the whole row is not obstructed, so whole row, it will be starting to guard. Okay, we have to go through the whole row again, whole row and column. So it will be something like g okay, into m plus n, okay, g into m plus n, because that whole row, okay, that whole row and whole column, okay, basically it we have to go for each g. That is the basic idea, to search which, that is to spread its, we can say, reach, to like mark those cells as guarded. For each guard I have to do that, okay. So this is going to be the time complexity of it, and this is space complexity will be simple. It will be O of m into n only, okay, because that we are not doing any fancy in that. So this is going to be the time complexity. And yeah, the space complexity is also very simple. Space complexity will be O of m into n, okay. Yeah, yeah, that is all for this question. This was slightly on the easier side. There are, like, see, optimized way of doing this, but see, this is not needed according to me, because you can explore that. But yeah, the way they have given this question, because see, oh, I mean, we are, see, not using anything extra here, okay. These are the worst case scenarios, remember that. But yeah, we have those checks here, because whenever we are seeing a break, that is, whenever we are seeing obstruction, we are breaking it out, okay. So we are just assuming this is going to be in the worst case scenario. Remember that. In the ideal scenario, this will not be this much time complexity, okay. So remember that we are just considering the worst case here, okay. So yeah, this looks to be like, yeah, slightly higher than m into n, but yeah, this is not the case actually, because see, idea here is I could have traversed the whole area again. See, try to understand how to reduce it, okay. So you can reduce the time complexity, but that doesn't mean your solution will be, taking less, compute power. That's not the case. Remember that. So see, what you can do is, for each row, you can travel once towards the left, and the second time travels from the end towards the right, okay. You can do both of these, okay. If you do this, you will not need to go through each guard and do all the things again, okay. That way you can remove that. But in this case, remember that time constant will be off element to one, but I feel it will be a more complex operation according to me. The number of operations will be more in that, okay. So though that is not captured by the time complexity, but that is, I can understand that it is more complex according to me, okay, in terms of compute power. So I'm not suggesting that approach. According to me, this solution should work great. And yeah, depending on the, like, see, they have not mentioned anything like how many, see, in this case, if you see this, again, they are like huge, okay, they are like huge. But that is the reason why, like, I'm not suggesting that approach. You can just do this should be a good approach. And like, yeah, if you are asked to, solve it to make it event one, then you can, talk about that. What you have to do is, like, go to the each row again. That is from left to right and from right to left. You have to visit it once, okay. That is for each row. You have to do two sort of traverses, left to right and right to left. This will ensure that all the guards are, like, reaching their uh, view to all the unoccupied cells, okay, as simple as that. And same for the what columns also. You have to go from down to top. That is, yeah, top to down and down to top, okay. You have to do it two times for each column. This way you can ensure that, yeah, it is m into n again, but yeah, the number of the compute that is happening is more according to me. So yeah, that was all for today. If you like my words, please do subscribe to my channel. This was the easier question, and let's see what comes tomorrow. See you tomorrow. Thanks a lot.